Welcome to Econ 317. In this instruction video, we will go over an example of income consumption curve. So the income consumption curve is the locus of the optimal consumption bundles chosen by a consumer maximizing his or her utility function given the prices of goods and income at hand when we change only the income level of this consumer. So I will start with price of good X. We have only two goods because we want to draw graph. So we'll deal with two goods. I will assume price of good X to be $1.2 per unit. I will assume price of good Y to be $1 per unit. And I will assume the preference of this consumer represented by the Leontief utility function. So preference is U of X and Y, which is minimum of 4X and 5Y. And then we will start with different levels of income and we'll keep changing the income to find out the optimal consumption bundle chosen by this consumer utilizing the given utility. I will draw an indifference curve for this utility function just to emphasize the shape of the indifference curve. So let's start with X on the horizontal, Y on the vertical, and I want to draw indifference curve for the utility level to be equal to 20. I will make it 40. So for this indifference curve, the Leontief utility function, the indifference curves are L-shaped. So vertical and horizontal, and we have a kink at the point of intersection. So I will assume the indifference curve to be having a utility of 40, which means we will have 10 units of good X, 8 units of good Y to be the point where we have this change in the slope. This is an example of indifference curve for the utility function when utility is fixed at 40. Okay, for this utility function, I will go ahead and write down the consumption bundle which the agent will choose, which the consumer will choose at different levels of income. So what I am going to do is I will write down X star, and this I want to write as a function of income because the income level is going to change. So I will write I for income. X star turns out to be 2I divided by 2, and Y star turns out to be 0.8 I divided by 2. Remember, I have fixed the price of good X, I have fixed the price of good Y, and so this is the relationship between X star, X star. These are the values of X star and Y star, which will maximize the utility function. I could also write it as X star equal to 0.5 I, Y star equal to 0.4 I, and now we can change the levels of income and find out the optimal consumption bundle. So let's have I here, X star here, Y star here, and I start with an income of $120. This gives me X star to be 60, Y star to be 48, I go to income of $180. X star is 90. Y star is 72. Then I have 240. You can see I am choosing these numbers appropriately so that we are able to get whole numbers for the values of X star and Y star. And I will have one more income level of income to be 300. X star turns out to be 150. Y star turns out to be 120. Remember, I have solved the optimal consumption bundle exercise for this utility function and the parameter values, price of good X, price of good Y, and income, and I have determined that solution, which turns out to be given by these two expressions. And then we are utilizing these expressions to find out X star and Y star, because our goal here is not to solve the utility maximization problem, but to use the choices made by the consumer, the optimal choices, to draw the income consumption curve. So now I will have X on the horizontal axis, Y on the vertical axis, and you could have seen the solution Y star and X star had this relationship where Y star is 0.8 times X star. So all the optimal consumption bundles were on this straight line. It passes through the origin. I will draw this line. It has slope of 0.8, and so our original budget set, if I go back to the original price, $1.2 per unit was the price of good X, price of good Y was $1 per unit, and let's say we have the income of $120, so I get 120 here, 100 here, and then we are not changing the income, which means, or we are not changing the prices, which means the slope of the budget line remains same, only the budget either moves out as we increase the income or moves inward if we decrease the income. So no change in slope, budget either moves out or moves in. And then the optimal choices are the point of the intersection. Again, if you recall, the indifference curves are L-shaped. So I will draw these indifference curves, which give us the optimal choices for the consumer. And so this is the income consumption curve. Given the income consumption curve, we are also able to draw the angel curve, which is the choice of good X, one of these two goods, at the optimal consumption bundle when the income of the consumer changes. So let me write down the values of income and X star to plot the angel curve. So this information is from the previous table I have already written. So when income is 120, we saw X star was 60, income goes to 180, X star becomes 90, income becomes 240, I have 120, 300, 150. You can recall X star was given as I over 2, or since I'm going to plot a function, a graph for income as a function of X star, I can write it as 2X star. And this is what I'm going to plot as the angel curve. I will have income on the vertical axis, X star on the horizontal axis, income on the vertical, and then you can see the slope, straight line with slope equal to 2. So I equal to 2x star. This is the angel curve. We have seen as income goes up, the consumer is going to buy more goods, which means good X is a normal good. As you earn more, you buy more. And this is a good point to stop.